This is the summit presentation for the Zebra RFID Capstone project. Our team was led by our technical directors, Gene Hoffer, a director of systems engineering at Zebra, and Joe Moreira, an engineering fellow. Our team was composed of 2 electrical engineers, myself, Remy Lloyd, and Ryan Hurley. The motivation for this project was focused on RFID wristbands. The anticipated best outcome of this project was the design and construction of a wristband prototype, which offered superior performance in read range and functionality compared to Zebra's current models. The anticipated best outcome of this project was achieved, as can be seen by the greater magnitude and directionality of the prototype designed by the team in comparison to the performance of Zebra's existing model. The economic impact for Zebra is positive. This new design creates a superior performance without a significant increase in cost. This is the block diagram for the project. My technical contributions consisted of design and construction of wristband prototypes, as well as testing and spacer testing, and also human testing and rapid testing.
My technical contributions consisted of prototyping and design of RFID wristbands. The picture here at the bottom is an RFID wristband. The RFID chip is this little line in the middle. The loop is used for near-field communication. This happens when the wristband is about within 3 feet of the antenna, and then these poles are used at longer distances. So there's 2 poles on each side, which is a dipole antenna. Then I made a 3D printed spacer right here. This simulates a 2-finger gap used to accurately measure the wristband spacing for people. So this way they're all put on the same with the same amount of spacing in between each one. Then I would rotate the wristband with this dot here as a measurement, 8 different angles around a wrist, and plot the results. So that shows up here, and we can measure the performance at different angles. Finally, I did some rapid testing. This was not documented, but just measuring different ideas and to try to pursue some that may be helpful. Initially, we needed a benchmark, so here is a benchmark of 30 wristbands. So this was 10 wristbands 3 times at 8 angles. Then we averaged all the results together, and that created this image in the middle. This is the existing performance. So it only works about 90 degrees maybe, and this is not ideal because if you were facing away from the antenna, for example, it wouldn't read at all. So the ideal performance is a perfect circle with the largest magnitude possible, which means it would read at every possible angle. And then we tested some spacer wristbands. So here is the initial wristband, the RFID wristband, and then underneath are 3 different thicknesses and materials we tested to try to separate the wristband from the people. People have interference with RFID, they tend to absorb it, and it makes it a lot harder to read. We then moved into the prototyping phase. So here is a copper antenna. So we cut thin sheets of copper and assembled an antenna out of them. We also made one out of aluminum foil actually, and it also proved effective. And we finally were able to print our own antenna poles with the thermal printer. So this allows us to upload an image such as these. These are 2 sets of poles for a wristband. We're able to print them out with a metallic film and then hand assemble them and create functional antennas. All of these designs did work, but didn't provide the best performance, which we'll get into later. Then we did rapid and human testing. We needed to compare the performance of the artificial arm to an actual arm. So here's a picture of me wearing a spacer wristband underneath with the RFID one on top. Then I would rotate this and measure the performance at different angles. This was to compare lab testing versus real-world testing. As in the real world, there's many other variables that can't be accounted for, and in the lab, we try to keep as many of them consistent as possible. here is a picture of just a fraction of the prototypes and tests we've done. Here is all the wristbands, and here's all the ones that we've assembled laid out. We've done a lot of trial and error, and we've created this. This is the polar plot of our best possible performance. The magnitude has increased so much it's actually going off the screen of the graph with a very, very high magnitude. This design is currently in the process of being patented. We would like to thank our director, Dr. Sunak, our technical directors, Joe Morera and Gene Hofer, and everyone at Zebra who has led their expertise on our project.